How can the simple spherical shape of a star explode to create such bizarre remnants? To investigate, astronomer Andy Howell enlisted the help of pyrotechnicians.
Well, a supernova, starts with a star that's spherical, and then sometimes the explosions are spherical, sometimes not. So it'll be interesting to see what we get here.
Okay, let's go over to the firing box and we'll try one out.
Awesome.
Okay.
Expecting to see like a plunger or something here, but
like the old days.
Are we ready to go? Yeah. All right, 3, 2, 1. Whoa! Whoa, whoa, that looks cool. Let's run that back and see it at the beginning. It's exploding in some not completely spherical way, and we see that in stars sometimes. When you light the star off-center, you can get an aspherical explosion. And wow, here we really see this plume of material coming out, messing up the spherical symmetry. And sometimes we see that in supernova remnants. You'll see some little jet that sort of shot out of the supernova. So it's not exactly a supernova, but it's pretty analogous.
Some other stellar explosions, as well as the planetary nebulas, are often split personalities. How can a star possibly start out as a sphere and then shoot out in two clear directions?
We're trying to demonstrate how some shapes we see in remnants are bipolar. Explosions happen not spherically, but they come out to the side.
A belt of dense debris may surround an exploding star in space. On Earth, a metal barrier between explosive charges does the same job.
Anytime there's an obstruction, of course, the energy is going to go where it has least resistance. It's going to shoot out.
Okay, so let's fire it, see what we get.
All right, ready to go?
Ready to go.
All right, 3, 2, 1. Whoa! When we made an explosion with a barrier in the middle, we get these beautiful lobes go out on either side. We see that in a lot of astrophysical contexts where you have a ring or a disk of material and it obstructs the explosion or the mass loss from the star, and you see stuff flying out in these lobes. In a lot of mythologies, the world ends by either cold or by fire, the real extremes of weather on the Earth.
But which vision of Armageddon does modern science support? How exactly will the world end? Could it be the frozen apocalypse, feared by the Vikings? It's 535 AD, and the people of a Norse village, so used to harsh winters, have never seen anything like this. Even the elders can't recall such a brutal season. Spring should be here, but the winter won't let go. Farmers can't plant crops. Livestock is dying. What if winter never ends? This truly feels like the beginning of the end of the world. It's winters like this that probably inspired the Norse vision of the apocalypse. They called it Ragnarok, or the twilight of the gods. Even the doomed pantheon of Norse deities was powerless to stop it. It meant the rise of monsters and the annihilation of gods and men. It starts with Fimbulvinter, a killing cold, worse than even a hardened Viking could imagine.
The Norse believed that the end of the world would be heralded by a 3-year mighty winter, following which the heavens and the earth would be destroyed. Perpetual winter, that's the end.
Could the end of everything come in cold, as the Norse predicted? Looking back at our planet's history, it's not hard to imagine. 3 times in the Earth's past, glaciers may have spread to encase the entire planet in ice and slush, like a giant snowball. Now, scientists predict something even more extreme. An icy apocalypse that will put a deep freeze, not just on Earth, but the entire universe. You are orbiting 55 Cancri E. It's mostly made of carbon, and due to extreme pressure and a surface temperature of 4,892 degrees Fahrenheit, it just might be a jeweler's dream.
Now think about this. What happens if you take a piece of carbon and you have the strength of Superman and you crush it like this? What do you get? A diamond.
If a diamond planet isn't strange enough, let's descend to another new discovery, HD 189-773b. Its blue color makes it look surprisingly like Earth. But in this case, looks can be deceiving.
This is a glass planet. It has mostly silicon, and the silicon with the sunlight passing through it appears to be blue, and it's very hot.
In fact, the temperatures near the surface are such that the silicate can condense into fine little particles of glass, so it might actually rain glass on this exoplanet. But that rain would move largely sideways because there are huge winds in the atmosphere, up to 4,000 miles an hour.
And the ancients never predicted a planet covered with a seeming impossibility: burning ice. Yet that's what we find on Gliese 436b.
If you touched it, you would be burned. This is a world made of hot ice. Something we never imagined on Earth.
Diamond planets. Planets of raining glass. Worlds of burning hot ice. Thanks to projects like Kepler, the universe is proving far stranger than either the ancients or modern astronomers ever imagined. But more is soon to come.